Today, we are pretty much going to wrap up any new material concerning exponents. Okay. So Monday and Tuesday, we're basically going to brush up on our exponents so that we can take our quiz on Wednesday. And just as a reminder, our CSA is going to be right before spring break. It's that Thursday before spring break. So next week we have a quiz, and then the following week we have the CSA. That way you have zero homework over spring break. Okay. You have Friday, but it'll be, but we're going to take the CSA on Thursday just in case it takes you a little bit longer than one period. Okay. All right. So we know that if I have x to the a times x to the b, I'm going to keep my base and we are going to add our exponents, right? We know that if we have x to the a divided by x to the b, we are going to keep our base and we are going to subtract our exponents. Okay. Well, now we have what's called the power rule. If I have an expression with a power and it gets raised to the power, any ideas of what we're going to do? What do you say? You got it. We are going to multiply our exponents when we have power to a power. Isn't that crazy? I know you feel it. Okay. So let me demonstrate to you why this rule is the way that it is. So if I have something raised to the fifth power, like a number 1, that means it's getting multiplied by itself 5 times, right? So we have 8 squared times 8 squared 5 times. Do you agree? Well, what does 8 squared mean? 8 times 8. Okay, so how many 8s do I have multiplied together? 10. 8 to the 10th. Now, do you want to draw this out every time? No. But what we can do is we can say, okay, we can take 2 times 5 to get our power of 10. So let's look at number 2. Do we have a power raised to a power? Okay. So we're going to take these exponents right here and we're going to multiply them. So this becomes negative 15th to the 18th power. I'm not going to make you put that in your calculator. Is that okay? How about you try number 6 one? do we get? 4 to the what power? 4 to the 4? 4 to the negative 4. So we would have to write this as 1 over 4 to the 4th. Okay. Somebody with a calculator, can you tell me what 4 times 4 times 4 times 4 is? Look at that. Okay, you and your elbow partner work together on 4, 5, and 6. Okay. So we'll talk about that.
Yeah.
We'll talk about it. Huh? All right. Denise, number 4. What'd you write down? Is she right? Yeah. You sure are, because we need to multiply our exponents. And then since we have a negative exponent, we need to rewrite it. Okay, I'm not going to make you figure out 2 to the 8th. Okay. How about this one? Bella, what'd you get? 10 to the 21st power. We multiply those exponents and hey, we have a positive exponent. That's great, isn't it? That's great. Also not going to make you put that one in your calculator. Okay. All right. Number 6. Quinlan, what do you have? 3 to the 3rd. Should it be -3?
Yeah, but it's not.
What?
It's not.
Oh, that's so sad. So that's why. Okay. So go ahead and write in that negative. So this should be 1 over 3 cubed, which we know is 27. So 1 over 27 is what we can write. Okay, is this gonna change when we move to variables? I actually think it's easier with variables if you want to know my opinion. Okay. So number 7, everybody, this is going to be x to the, and by everybody I heard 2 people. 9 times 3 is 27. This is x to the 27th. Okay. Number 8, this is going to be a to the 14th power. And then in number 9, since we have a power to a power, we're going to multiply our exponents to get k to the -20. I do expect you to write it as 1 over k. All right, now what do you notice about number 10? Oh my gosh, there's more than one variable, right? There's 2 variables. So first of all, what power does C have? Okay, so C has the power of 1. So what we're going to do this with both of them. We're going to take 1 times 4 for the exponent of C, and we're going to take 2 times 4 for the exponent of D. So this ends up being C to the 4th, D to the 8th. So number 11, same thing. Since we have a power to a power, we will take -2 times 3 for the exponent of m. We will take 8 times 3 for the exponent of n. Now, what is -2 times 3? -6. And 8 times 3 is 24. So I would expect you then to write this as n to the 24th, but then m to the 6th needs to move to the denominator. Okay, so let's move down here to number 13. The rest of the examples that we're going to experience today are going to have some coefficients, okay? Well, I want you to remember that if you don't see an exponent, it's assumed that the exponent is 1. So this is like 3 to the first x to the 7th, all being raised to the 2nd power. So if we apply our power to a power, this becomes 3 to the power of 1 times 2, and x to the power of 7 times 2. Yeah. So this is where I am going to expect us to now move that one step forward. I don't want you to leave 3 squared. I want you to write it as 9x to the 14th. Need to get in that practice. What? Is that a problem? 3 squared? Are you okay with how I got 3 squared? Okay. So let's talk about 14. If we don't see an exponent, we assume it's 1. So since we have power to a power, this becomes 5 to the 3rd power and n to the 12th power. Now you do have a calculator. However, we also know what 5 to the 3rd power is. How about you and your elbow partner talk through 15 and 16? All right, so going back about number 15. Ryan, what did you get for number 15? How do you feel about Ryan's 100x to the 14th? Okay, we have 10 squared times x to the 14th. I really like that. Okay. All right. How about number 16? Trent, you want to share your answer?
4 to the 4th power over w to the
28, yeah.
Yeah.
You're good. Yeah, so I do want you to write this as 256 over w to the 28th. Okay. So we have 4 to the 4th times w to the -28. So then we... All right, let's go ahead and slide over to that next page. I want to talk about this guy right here because we have -7. Okay. So we are pretty good about knowing that this needs to be a to the 16th power and b to the 6th power, right? Power to a power, we're multiplying those. Do you agree? Okay. Now, that -7 gets the power of 2. But what did I tell you about negative bases? They need those parentheses because -7 squared is really different than -7 squared. So if we take -7 and we square it, what number do we get? What's -7 times -7? It's a positive 49. That is different than if you put negative and then 7 squared. So then let's talk about 20. 20 is pretty similar, isn't it? Okay, so we have a -3 as a base. So when we take this 3 as the exponent and push it through, -3 gets the exponent of 3. What is m's new exponent? -6. What is n's new exponent? -15. All right, now -3 cubed. What is -3 times -3 times -3? -27. Okay. And then m to the 6th and n to the 15th would have to push to the denominator so we could rewrite those. We're going to do number 22 and then the rest of the time can be for homework. Okay. In number 22, this is a little bit different because we have that negative exponent. Okay. So this is what I'd like you to do. Let's just one step at a time. We have 2 that gets the -4th power. We have a, we need to multiply those exponents. So we get a to the -20th. And then we get b. Ooh, what happens to b? It's a +8. Okay. So b to the 8th gets to stay in the numerator. But then 2 to the 4th and a to the 20th needs to come downstairs. Brady, you're good at these. What's 2 to the 4th? You don't need a calculator.
Actually, wait, no,
16. Okay, so I do want you to go ahead and make 2 to the 4th 16. Okay, go ahead and turn to page 13. On page 13, I'd like you to do 1 through 12. On page 13, 1 through 12. Maybe not today.